Welcome back, everyone, to the final live stream of the live CTF during the DEF CON CTF qualifiers. So this is an extra stream that we added because of the technical difficulties we had with challenge number 4, Test Your Luck. So what we ended up doing there was that we extended the deadline until just about 15 minutes ago, and we made it worth a static amount of points. So we removed the fall off from that. And this means that we added this stream to talk about this challenge because we haven't talked about it before. So I have Glenn and Josh with me here. Jordan is just about to take off on a plane, I think. So he's not here, but he's in the chat for a little bit more, I guess. But yeah, so this challenge was created by Josh, so I'm going to hand it over to him to talk about the challenge and the solutions.
Yeah, so the challenge was a relatively straightforward one. First off, imagine having a CTF challenge at a static number of points, just unheard of. But the fact that it had to be held at a static number of points, I think, was the right call. It is what it is. Running a CTF is hard. So getting through the actual source of the challenge, I feel like a lot of teams already kind of fully reversed it. There were some teams in past challenges that were so kind as to send us their IDBs along with their exploits, so thank you for that. But this one, I don't think that was the case. So let's walk through. So we get to main, and the name of the challenge is Test Your Luck. So as you can imagine, you test your luck. You read an integer in, it checks if it's equal to a random value, you win, and it just returns, which doesn't exactly seem like a pwnable. So this aspect of it, as you might have noticed if you ran the binary, was it doesn't go immediately to main. The life cycle of an elf is more than just a high fantasy Hallmark movie. It is kind of complicated and something that a lot of people don't understand. So going from the top, we have a syscall that was left in as a symbol because it would just be annoying to reverse without it. You have a random state that was pre-populated with Turbo Pascal LCG values because, well, yeah, because why not? Initial rand value. Then you get this funky stuff: init array start, end, exec start, fin array end, and data start. These are important. These are populated with the address of the init array start and end, and obviously fin array end, executable start. This gets leaked to you as an initial print, and data start. I'll explain these in a bit later. The init array start. Init array is something in an elf that is called kind of on startup. So we see here we have the sub function, which goes through and it calls the register TM clone table. And we have an init rand val. This is what goes through and it actually initializes the random state with the LCG values. So kind of how do you get that value? How do you solve this? And what does returning from main even do? So we have, where is it? Real man. Here we go. So I set the pre-init array, which is something that gets run even before the init array, to these three functions. We have early mprotect, do pre-init, and late mprotect. So early mprotect here goes through and it mprotects, well, it inline mprotects because I didn't want called encrypted. And what it does is it goes through, sets that to RWX, then do pre-init is called. That gets, well, first off, it sets the init array first entry to real main. Then it goes through the encrypted block and XORs it with OX41. Then late mprotect is called, and that sets it back to just RX. Real main is what gets called from the init array. But you might notice from reversing this binary that the code you get back doesn't actually look like this. That's because in the actual challenge, here, which I have symbols in this one, and where is it? Oh, this is the unencrypted challenge, my bad. 3-init array, and here, and here. Yeah, so this is real main in the challenge handout you get, and this looks terrible because it's all Zored with 41. So you can either go through manually Zor this section of code, or you can dump it from memory, or get it however you want. Once you get this, you'll see that the real main function gives you a leak of the executable start. Then it reads along. It checks if it's in the range of the got, which there is no got start end, so I have to use fin-array end and data start to check this. And it breaks if you give it a 0 as the address, just so you're not stuck in here forever. And then it's an arbitrary write. So it reads value to be put at the address you gave it. Easy peasy. And yeah, all this inline readline stuff, I just didn't want to give so many got entries here. I want to make it kind of a challenge. So once that's done, we drop through to real main, and then we get back to what we already talked about. So what do you do to solve this? Well, what you can do is in real main, and I actually have my solution here, you overwrite the second init array function that you're not in yet that initializes the random values. And you can overwrite that to whatever you want. I overwrote to early and protect because this is the shortest solution, the intended solution. And what that does is instead of initializing the random value, you get that encrypted region of memory, or encrypted section, RWX, which you have an arbitrary write. You can imagine this is going to be really useful. Then what you can do is you get to the fin array, which in an ELF is usually just like a global destructor list. But here we override it with the next function we want to call, which is back to the real main write arbitrary write loop. So once you win the guessing game, because you know the initial value is what I think just the initial state of the LCG, which is that constant. Main returns, you get your fin array called, and then you return back to your write loop. So now you have an RWX write page, or an RWX page. You have arbitrary write, and you have a leak. So it's pretty much over at this point. The name of the game is just figuring out where to jump to, what to change, what code to change. So kind of a little bit of a challenge here was you have to modify something in that page while you're running code in that page. But there's enough space at the beginning of the function here that, where is it? Yeah, like you're in this loop, you have all of this space to work with, which is 40 bytes. And your shellcode should be like, I don't know, 30 bytes or something, including bin.sh. So that's just a matter of overriding the beginning of the write loop, which we do, where is it? Yeah, here we go. So we write bin.sh to, I use the BSS. We write shellcode to the beginning of the write loop, and I just do it, or you have to do it in chunks of keywords here. And then I just write a jump to the shellcode at the beginning of the loop body here. And then it jumps back to my shellcode, and we get code exec. I haven't seen, just scrolling through the solutions, anyone that did it differently than this. It looks like this is kind of the formula. This is the second intended solution from Glenn. And yeah, just goes through. Instead of calling bin.sh, like people called the submitter. But yeah, that's pretty much how this challenge was written, solved.
Nice. And how?
And I'm hopeful. Yeah.
Sorry, I cut you off there.
No, it's fine.
Yeah. No, I was just thinking like it looks very nice. Like, so what did we say about the teams and the solves, and how many solves did we get, and do we have some of the challenges to look at?
Yeah, there were, I want to say, 29 solves. And let's see, I'm not sure about the time of these solutions. I think people just resubmit immediately because they're solved in 7 seconds, 10 seconds, like really close to each other. All the solutions really used the same format. Like this one was bin.sh to executing submitter. Or was it? Yeah, printing code base. Actually, binary base, not code base. I don't think, but that would be writing. Oh, we can actually check 4338. Oh, okay. Wait, this is different. So they actually overwrote the proper like set entries, like the dynamic header entry. So they changed the pointer. Oh yeah, that's kind of clever. They just changed that around. And
Instead of changing the contents of the array, they changed.
yeah, so they just completely sidestepped. Instead of changing the contents of the array, they changed where the array was, pretty much.
Yep. Yep.
I like that. That's a clever solution. I don't know how I didn't see this one. That does save you having to go through and actually win the guessing game. And yeah. Let's see, PyLeak. Oh, they did the same thing. Okay, so there are two camps that people fell into, it looks like.
Really cool to see. Glenn, you did a test solve of this challenge, right?
Yeah.
And
yeah.
Oh wait, I have your sound here. Hold on.
No, you're good.
Muted on there. Okay, I see. Like
we gotta you see behind the curtain a little bit. We're just gonna casually get really good at toggling the mute back and forth.
Oh yeah, I see. Is it that bad? No, but I was just gonna ask. You test solved this challenge, right?
Yes.
What was your approach?
Was basically the same as what Josh outlined, in that I overwrote the last entry in the init array and I overwrote the finalizer array, and yeah, just wrote my shellcode at the start of the RWX segment, and then I guess Josh wrote the jump at the start of the loop. I wrote the jump at the end of the loop and just finished the loop because I don't trust my code to go where I tell it to.
Oh, right. So because then you can just, like, if it's too long,
Yeah,
you
then
can
you
just
just exit.
trash whatever comes after. It doesn't matter. Yeah. Okay. Yeah. That's nice. Yeah.
And it says the flag should just fall out, and indeed it does. The shellcode I wrote is a little bit different than the shellcode that Josh wrote, just because I gave up trying to assemble reasonable shellcode. So it literally pushes the path to the submitter 8 bytes at a time and then reads the address off the stack. Is like, I don't need a data segment. I don't need to write anything to BSS. It's just one-shot shellcode.
Yeah. Nice. Yeah, I guess that's basically it for the challenge. Or any other comments, Josh, about this?
I mean, it was a fun challenge to write. Originally going to be a lot harder, and then I remembered it's LiveCTF. So I don't know, if we do this again, maybe we'll make it harder, because it looked like team solved it pretty early.
Yeah, that's. I mean, I think. I mean, it's hard to judge now with the, like, when we changed it around, how long it actually took teams to solve it, but it did seem to be fairly. I mean, in line with the other challenges we've had here during the LiveCTF.
I'm glad it got a good number of solves, like 29. I'm very happy with that. That it wasn't 200 and it wasn't like 5. So that's right in the middle good range.
Yeah, and with that, then that marks the end of the LiveCTF portion of the DEF CON CTF qualifiers. The qualifiers runs for another like 8 hours or 7.5 hours, I think. Yeah. So there's still room to shake it up in the scoreboard. looking at the scoreboard right now, it's extremely tight around the. So the 11 teams plus MMM, who are, if I understand correctly, currently in the top 12. So currently the top 12 teams will qualify, and it's extremely tight, like team 12, 13, and 14. So it's going to be really interesting to see the teams fight for that last 12 spot to the qualifiers. Or I mean, even there could happen things higher up on the scoreboard as well. But I just noticed that it was very tight just around the qualifying limit.
They'll probably merge after the fact if they don't make it.
Oh no!
Someone's got to make one of those big diagrams like last year, where they had like the 50 to 100 teams all combining into 16. Well, now it's all combining into 12.
Yeah, everyone just plays one team against the organizers. Like not the team. Yeah, okay.
Organizers.
Yeah, whatever. You know what I mean. Okay. Cool. So I hope everyone had fun with the live CTF. We hope that the technical issues didn't cause too much of an issue. I think we tried to solve it in a good way. And yeah, good luck with the rest of the CTF. And thanks from us and the live CTF team. We have Jordan here in the chat as well. Yeah.
Who's actively flying home right now.
Yeah. Well, goodbye.
Thanks,
Yeah,
y'all.
bye. Thank you.